Okay, now for example number 1, we want to find the area between two curves. We want to find the area of the region bounded above by y is equal to e to the x, and then bounded below by the equation y is equal to x, and then also bounded on the sides by x is equal to 0 and x is equal to 1. So it's important to make sure that you draw this either on a graphing calculator or by using Desmos. So when you draw the graph of y is equal to e to the x, that's going to represent this red line, and then y is equal to x represents the blue line. And then it's bounded by the sides x is equal to 0, which is a vertical line here, and then a vertical line x is equal to 1, which then shows what's your area that you're looking for, which would be represented by S or A. Now the region is shown here in a figure. And again, the upper bound, we know what the upper bound curve is. We know the lower boundary curve. And then we're going to use the area formula to then find out what the area would be inside that curve. So we know the lower limit is 0. We know the upper limit is 1. We're taking the upper boundary curve e to the x, subtracting the lower boundary curve x dx. Taking the antiderivative of those functions, you get e to the x minus 1/2 x squared, and then evaluate according to the lower and upper limits. As we substitute them in to our results, then we end up getting the area e minus 1.5. Now, in figure 4, as you can see, we drew a typical approximating rectangle with a width of delta x as a reminder of the procedure by which the area is defined in definition number 1. So in general, when we set up an integral for an area, it's helpful to sketch the region to identify the top curve. In this case, we're going to call it y subscript t, and the bottom curve is y subscript b. In a typical approximating rectangle, as in figure 5. Okay, and we'll see what that looks like here. So therefore, you have your yt minus yb times the length delta x. Excuse me, the width. Excuse me. There's your length, there's your width. Now, if you look at this as according to a limit, then we get the similar definition in 1. And again, it summarizes the procedure of adding, in a limiting sense, the areas of all the typical rectangles.